Here it is. 1/2 raised to 3x minus 1 equals 64 raised to x plus 2. So this is an exponential equation. Yes, you can always apply natural log, for sure. However, it is so much easier than that because both sides can be presented with the same base. The left-hand side will be 2 to negative 1, and the right-hand side will be 2 to the 6th. So if you notice that, it's the best. Now, if you say, but what if I don't? That's fine too. You will still get the same answer. But you will work a little bit harder by applying natural log to both sides. And you may or may not get the final simplified form of the solution because you may not think of simplifying it. Okay, so we copy the base, multiply the exponents. Copy the base, multiply the exponents. Two numbers are equal and they have the same base. Therefore, the exponents have to be the same, which means negative 3x plus 1 has to equal 6x plus 12. I move 6x and I move 1. So this is negative 9x equals 11, or x equals negative 11 over 9. There are no restrictions on exponential equations. So whatever you get, unless you made an error, you should be fine. There's nothing else to say here. Now, if it's a log equation, it's a different story. So if you'd like to redo the problem we had, the log equation we had on this test, that is a different situation, which is log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. For such an equation, I have to state restrictions. If you don't state restrictions, it's still okay, but you have to go back and check in the original problem. It's up to you. It doesn't matter. Okay? So I write that x minus 1 is positive, that x plus 3 is positive, and that x has to be positive. For this to be positive, the denominator must be positive. From all these three conditions, we get that x has to be greater than 1. So if I do not get a number as the solution, a number that is greater than 1, I will say, sorry, it's not acceptable, and it's done. So then we condense the left-hand side as x minus 1 over x plus 3, and we keep the right-hand side. Two logs are the same, and they have the same base. Therefore, this expression must equal that expression. Do not cross out anything. This is not what we're trying to do. We write that x minus 1 over x plus 3 equals 1 over x. And this is a proportion now, and we will cross multiply and get x squared minus x equals x plus 3, or x squared minus 2x minus 3 equals 0, or x minus 3 and x plus 1. And we get two options, S3 and negative 1. But I know that I worked hard at the very beginning, so I know that the solution will not be accepted unless it's a number strictly greater than 1. This does not belong there, but this one does. So to this one I will say yes, and to this one I will say no. If I don't do this, then I have to go back and check in the original problem. Whichever method you prefer, I'm fine with both. But you have to choose one. Okay? Okay? What other type of problem we would like to look at? Next question, anything else? So let's look again at this test, maybe graphing or finding x and y intercepts. A system. Solving a rational inequality. Anything else? We have 5 minutes. Let's use them. Can we pick another problem? Remember, I'm expecting you to present your work for full credit, right? So if somebody happened to punch in a number in the calculator and they got 1.5 weeks without showing all this work. Yes, Brian, please.
How do you think that problem needed anymore? You can solve it without.
You can't.
If you solve problem 9.
You cannot.
At problem 9,
You can. You cannot come up with 1.53 without performing these calculations.
maybe not 1.53, but you can.
But I'm not asking for an estimate. I'm not asking for an estimate. I'm sorry.
You rounded up the answer.
Right, because the answer is very long. It has infinitely many decimals, not what you plugged in. So sorry, I can't. A student who shows this work cannot get the same number of points as somebody who comes up with 1.5 by chance. This is a method that works in all situations. Plugging the number, it's by chance.
I'm just saying you didn't need to plug the number in.
Okay.
So
Okay. How did you solve it?
if you look at number 9.
Yes, let's look at number 9. Yes, go ahead.
So for number 9,
Yes,
when I was initially solving A,
yes,
I made the mistake and I put 1, t equals 1 instead,
yes,
right? And I got
yes,
around 5,000 people.
yes,
And then when I was solving for B,
yes,
for 4, I
yes.
got 28,000 people.
Okay.
But originally, I had made the mistake and put 3 in for T, and I got
And
about 15,000.
how is that not by chance?
It wasn't by chance. It was just
A
you
mistake.
could tell the increments as to which
Okay, so
the average
but if
amount
I
of people
but if I
increases.
come to you and I present this material and I say, let's just plug in 1 and see what happens. Maybe we should plug in 2 and see what happens. Maybe we should plug in 5 and see what happens. What would you say? What's the method? How are you just plugging in numbers? Why can't you just plug in -5?
But you can plug in
But this is not what I'm asking.
3 numbers
I'm not
and then find the increment as to which
I'm
those
not
3
asking that. I'm so sorry. I'm asking for solving this is a sophisticated equation. Not everyone can do this.
I get it.
If you practiced enough, you will have no difficulties with it. But if you haven't, you will have difficulties with it.